Okay, so in this example I have $10,000 and I want to make it $20,000. I want to invest it and see how long it takes. So the question is, how long does it take $10,000 to become $20,000 at 11% interest? Now, I don't quite have enough information here, so let's do this in parts. What if I did this yearly? So let's do that first. So the total amount is equal to the principal times 1 plus the interest rate over n times nt. So the total amount, I know the total amount, that's 20,000, and the principal is 10,000. 1 plus 0.11 divided by 1, and then 1 times t, and it's t that I'm solving for, and t will be in years. So if I were to simplify this a little bit, divide both sides by 10,000, I would get 2 equals 1, and then this is 1.11 to the t. And I would use logs, so log 2 is equal to log 1.11 to the t. Bring the t down. Log 2 is equal to t log 1.11. Give myself a little bit more room here. And t would be equal to, divide by log 1.11. And again, I need my calculator to solve this. And I get about 6.64 years. So it's going to take a bit of time, and that is a very, very good interest rate for our current economy. What happens if I up this and I say monthly? Well, what changes in my formula? The A is still 20,000, and the P is still 10,000. 1 plus the rate, which is still 11%, but now this becomes 12 and this becomes 12t. And as I do the same steps, so divide both sides by 10,000, this interest rate gets a little bit trickier. I actually have to take my 11% and divide it by 12, and I get 0.00916 repeating, and I'd use my storage button on my calculator, maybe call that the letter A, just so that I can use logs a little bit better with it. Now I want to log both sides, so I get log 2 is equal to, and you'll notice what continuously happens. I'm going to log it, and then I'm going to bring that exponent down. So I'm just going to save a step, bring the exponent down right away. 1.00916 repeating, or log of A, and then I get 12t is equal to, I have to divide log 2 by my log A value, and then I have to divide that answer by 12 to get my final answer for t. And it's good practice to do this on your calculator, so maybe pause the video, grab your calculator, and actually go ahead and do this. And you should find out that it's now 6.33 years. Yeah, I've saved myself 0.31 years, which is a few months. That's not too bad. What happens if I up it even more? And I'm going to go as fast as I can on this one, as in, let's do it continuously. Well, I have a new formula. It's A equals PE to the KT, and A is still 20,000 total, P is 10,000 starting, E is E. My rate, my K value is 0.11 times T. So divide both sides by 10,000, 2 is equal to E to the 0.11 T. And then go ahead and log or ln your way through this. So log 2 is equal to, when I log this, the 0.11t will come down, and I get log e, and divide both sides by log e and 0.11. So I get log 2, it's going to get divided by 0.11, and it's going to get divided by log e. And go ahead on your calculator, make sure you're using brackets on the bottom, and see what you get for this one. And we do shave off a tiny bit of time, 0.03 years, which is days, but it is a little bit faster to generate your doubling of your money if you can get continuous growth. Now, of course, if you owe money, you don't really want continuous growth increasing the amount of money you owe. So banks like to use continuous growth all the time because more people owe than have, and they can actually make a lot of interest off that extra amount rather than charging people monthly or yearly or bi-yearly or anything else. Okay, we'll practice some more in class. See you then.